This is an example where we need the topic will be finding intervals where the graph of a function is concave up or concave down. So let's do this example. Let f of x equal 1 over 2x to the fourth minus 2x squared. And then first question, we need to find the derivative, f prime of x. So the derivative will be 4 times 1 over 12, which is 4 over 12x. And then 4 minus 1 will be 3. Minus 2 times 2 is 4x. 2 minus 1 is x. So this will be equals, just simplify it, divide by 4, you get 1 over 3x cubed minus 4x. Now for the second question, we need to find the second derivative. So second derivative will be the derivative of the derivative. So 3 times 1 over 3 is 3 over 3x. 3 minus 1 is 2. Then minus derivative of 4x is 4. So second derivative is equal to 3 over 3 is 1. So it's x squared minus 4. Good. Now C, we need to find x interval where the function is concave up or concave down. Before we do that, we need to set the derivative equal to 0. Let's do that. And then find those critical numbers. So the derivative is equal to 0, means x squared minus 4 is 0, means x squared is 4, it means x is minus or plus 2. And then what we do, we plug them into our domain, so minus 2 and 2. The second derivative, we said it's x squared minus 4. We know it's equal 0 when x is equal to negative 2. We know the second derivative is equal to 0 when x is equal to 2. Now all we need to find is the signs of the second derivative. So let's pick some numbers. So let's pick a number between negative 2 and 2. So that would be 0. So second derivative of 0 is equal, I'm plugging it into the second derivative, so it's 0 squared minus 4, which is minus 4 less than 0. So I know second derivative is negative between negative 2 and 2. Now let me pick a number on the right of 2. So I'm going to pick 3. Second derivative of 3 will be, I'm plugging 3 into the second derivative, will be 3 squared minus 4. 9 minus 4 is positive, it's 5, positive. So I know this is positive. Now I need to test second derivative for x between smaller than negative 2. I'm going to pick negative 3. Second derivative of negative 3 is negative 3 squared minus 4, which is also 5, positive. So it's going to be positive. So now I know this is concave up, concave down when it's negative, and then concave up. What's next? To find inflection points happens where the concavity changes. So definitely at x equal negative 2, concavity change from concave up to concave down. In other words, that's an inflection point. So let's call it P1. P1 will have x equal negative 2, and we can find the y later. Now, same thing, at x equal negative 2, the concavity change from concave down to concave up. So that's another inflection point. So let's call it P2. And that happens in 2. So all we need to find is those f of negative 2 and f of 2. F of negative 2 means we need to plug negative 2 into our original function. If we do that, we'll get 1 over 12 negative 2 to the fourth minus 2 negative 2 squared, which is equal to 16 over 12 minus 2 times 4 is minus 8, and then minus 8. And that would be equal to, let's simplify, divide by 4, I'll get 3, divide 16 by 4, I get 4, and then 8 is just 3, 24. 4 minus 24 is minus 20 over 3. So I'll go here and write minus 20 over 3. Now what about f of 2? If you notice, f of 2 will be the same thing because we're going to plug it in. If you plug it in, you get 1 over 12, 2 to the 4, minus 2, 2 squared. It's exactly the same, so it's negative 20 over 3 because the exponent is even. So that would be negative 20 over 3. So we have two inflection points. And that's it for our example.